Hi everyone, this is lesson 4.1 for Math 1315 College Algebra. Probably if you're watching this, I have handed you the video notebook handout already, and it's probably already filled in. So due to the fast pace of this class, 4.1 as well as 4.2 are basically just given to you as take-home notes. So they're supposed to be review. You'll recognize hopefully all of these topics in these two sections as having been covered in the previous class before this in intermediate algebra. If you did not take that class at Metro or it's been a while, you might benefit from watching through these videos and looking through the notes. The homework is required. 4.1 and 4.2 homework is required, but we won't be having the full lesson during class time, which is why I'm making these videos. So what you might do is look through the notes and try the homework on your own. And if that's working for you, then great, you don't need to watch through. If you're looking this over and feel that you do need a more involved refresher, then that's what these videos are for. So before we get going, let me just remind you where to find what I have on the screen here. Again, you should already have a handout that I've handed to you, and I've adjusted that a little bit. So, I might have changed the font size and cut down on some of the examples, etc. But the content is generally the same. So this will look a little different from what you're holding in your hand to write on and to follow along with. But again, it's mostly the same. Where you can get this exact copy is in Canvas. So let me remind you about that. In our Canvas course, you would click on Modules. And this is in Unit 2. So you would go to Module Unit 2. I was just there, but I'm kind of going back just to remind you of this. So again, in our Canvas course, click on Modules, maybe click Collapse All in the top right corner so that they're all easily visible. We're in Module Unit 2. You would click on Learning/Lecture Materials. And this is where you can find all the copies of the video notebook documents. So I'm scrolling down, they're all in these PDF forms. Okay, so I already clicked on video notebook section 4.1 and I opened it in a different tab. So I'm gonna go back to that one. And then of course there's 4.2 as well. Starting with section 4.3, we will cover that one during our class time. But 4.1 and 4.2 are meant to be review. So the expectation is that you're doing the assignments on your own and doing any review on your own that you might need. Okay, so in section 4.1, we're doing an introduction to polynomials and polynomial functions. This section specifically is all about polynomial expressions starting out. So here's some vocabulary to know. A monomial, think mono meaning one. It's a polynomial with one term. So it's a constant, which is a number like 4, or a constant times some variable like 4x, or variables raised to powers that are non-negative integers. For example, 4x to the third. Okay, and you see some examples down below of some polynomials. 3, for example, is a constant, 2x, negative 4y squared, 7a to the 4th, b to the 8th, etc. So these are all examples of monomials. There's only one term. If you're wondering what a term is, once you start seeing expressions that have plus or minus signs in them, the plus or minus signs separate the terms. And I think we see that written in a sentence up here. So a monomial has one term. A polynomial or polynomial has many terms. So poly means many. So again, a polynomial is a monomial or a combination of sums and or differences of monomials. So the word polynomial is more of a broad term, a broad vocabulary word. It does include monomials or binomials, trinomials, etc. So it's really sort of this broad concept that includes expressions that have one term, 2 terms, 3 terms, or more than that. So here's some examples. Polynomials in one variable, 4a to the third, 2y plus 1, x squared plus 5x minus 6. Those are all examples of polynomials. The first one is a monomial with one term. 2y plus 1, that's an example of a binomial with two terms. Notice the plus sign in between. X squared plus 5x minus 6, that has three terms. That's a trinomial. And then there's some more examples down below. Sometimes polynomials can have more than one variable, so it might have x and y. And that's what these examples are showing. Sometimes there's x, y, and z. Okay, so the way I think of these is a polynomial might be, if you think of it like a phrase, like a collection of words, each word is a term. That's kind of how I think of it. If that analogy doesn't work for you, that's fine. So I don't know, that's just how I think of it in my brain. So down here with trinomial, x squared plus 6x plus 9, there's three terms there. You can kind of think of it as like three separate words. Okay, so there's some more vocabulary coming after that. Coefficient is the next one. So the coefficient, that's basically just the number part in front of a variable. So it says the coefficient is the part of a term that is a constant factor. So for example, let's see, in this monomial where it says 2x, 2 is the coefficient. It's the number in front of the variable. Or 3 is a coefficient. It's just a constant term. All right, so the coefficient is the part of a term that is a constant factor. In math, when we see the word constant, that generally just means it's just a number, okay, not a variable. Okay, did I get all that? Let's see. The coefficient is the part of a term that is a constant factor, so just a number. A constant term is a term that contains only a number and no variable, like this example of 3 up here. Okay, the degree of a term is the sum of the exponents of the variables if there are variables. The degree of a non-zero constant term is 0. The term 0 has no degree. Okay, so basically if there's an exponent, that's your degree. If there's more than one exponent within the term, you add them together. We're going to see examples of all this very soon. Okay, but just to give a really quick one, up here, if we see 7a to the 4th, b to the 8th, that's all one term. The degree would be 12 because we would add 4 plus 8. All right, now, once you get more than one term, it's a little bit trickier. The degree of a polynomial is the same as the degree of its term of highest degree. Okay, that's kind of a tricky sentence to understand. So here's how I see it. You look at the polynomial, you look at the degree of each term separately, and then you pick the highest. Let's do a quick example of that. So I'm going to use x squared plus 6x plus 9 as an example. The first term has a degree of 2 because the exponent on the x is 2. The second term has a degree of 1. Because remember, if you don't see an exponent on the variable, it's really a 1. The last term of 9, since there's no variable at all, the degree there is 0. So notice how we found the degree of each term separately. The highest of those is 2. So the highest degree between 2, 1, and 0 is 2. Therefore, the degree of that polynomial is 2. So that's the degree of the whole thing, the degree of the polynomial. And again, we'll see more examples of that. Okay, so something that people can get mixed up with is when to add the exponents and when not to add them. So if they're together in the same term, that's when you would add them. If they're not together in the same term, then you would not. So here, one more quick example from the binomial row here. Okay, so x squared y, that's one term, plus 4xy to the third, that's a second term. Let's find the degree of each of those. So x squared y, the degree there is 3 because we get to add the exponents. They're in the same term. The x squared and the y are kind of glued together by multiplication. Again, why am I saying glued? That's just how I think of it. They're together. So they're in the same term. We add the exponents. The degree of that term is 3. Then we move to the next term, 4xy to the third. The degree there is 4. How did I get that? Let's see. I added the exponent on the x, which is 1. And then the exponent on the y is 3. 1 plus 3 is 4. The 4 is a coefficient, so we don't really need to worry about exponents on that. It's just kind of there, again, as a coefficient. To find the degree, we're just adding exponents on the variables. Okay, so just to recap, the first term has a degree of 3. The second term has a degree of 4. the degree of the whole thing, so the degree of the whole polynomial, is the highest between those, which is 4. So highest. So notice it's not 7. We're not adding 3 plus 4 is 7. We already added within each term, but to take the degree of the whole polynomial, you're taking the whichever term has the highest. Okay, let's see some other vocabulary. Leading term is the next one. The leading term of a polynomial is the term of highest degree. So in this example up here, 4xy to the third would be the leading term because it has a higher degree. Its coefficient is called the leading coefficient. So in this example, that 4 would be the leading coefficient. Okay, then we have descending order and ascending order or ascending order. Descending order is the one that you'll want to know best. Descending means going down. So from highest to lowest. So arrangement of terms so that exponents decrease from left to right. So an example of that would be right here, the x squared plus 6x plus 9. That is currently in descending order. We have the highest exponent first, or the highest degree first, and then the lowest degree last. That's a very common way to write our polynomials. Sometimes you might be asked to put something in ascending order, so going up, increasing, so arranging the terms so that exponents increase from left to right. Again, this is going to be much less common, but you might see that word used. So descending is going down from left to right, highest to lowest, and then ascending is lowest to highest. And then we're going to see an example, and I might have already done some of these. Let's see. So here's a table filled out. Identify the terms, the degree of each term, and the degree of the polynomial. So here's our polynomial, negative 6x plus 4x to the third plus 5 minus 3x squared. Then identify the leading term, the leading coefficient, and the constant term. Finally, write the polynomial in both descending and ascending order. And that's already been done for us. So notice how we split up those terms, kind of the pieces, right? So we found the degree of each term. The degree is essentially the exponent, if there is one. If there would be more than one variable, we would have to add the exponents together, but that was not necessary here. So negative 6x has a degree of 1. 4x to the third has a degree of 3. 5 is just a number, a constant number that always has just a degree of 0. Negative 3x to the second, or negative 3x squared, has a degree of 2. Okay, so of all of those, the highest degree is 3. Therefore, the degree of the polynomial is 3, which means 4x to the third, that's called the leading term. Even though it wasn't leading in the beginning, it wasn't listed first, it's called the leading term because it has the highest degree. That means 4, that number part, is the leading coefficient. And then the constant term in this polynomial, it's the one that's just the number without any variables on it, and it happens to be 5. That's the plus 5. And then finally, look at how these terms could be arranged. Descending order is the most commonly used order to write our final answers, but sometimes you might do ascending order. So notice it's going from highest exponent to lowest, 3, 2, 1, 0. So 4x to the third minus 3x squared minus 6x plus 5. If you just reverse that, 5 and then minus 6x, then minus 3x squared, and then plus 4x to the third, that would be ascending order. Alrighty. So now we get to fill some in on our own. So here's example 1. And again, probably if you're watching this, you already have versions of this handout in front of you. And I think I was trying to be helpful by already filling it in. So you might be, again, just looking at something that's already filled in, but feel free to just write this out on your own or just follow along. All right, so here we go. Identifying terms, degree of each term, degree of the polynomial. So negative 6y to the fifth minus 2y minus 4y to the third plus 12y to the ninth plus 10. All right, so let's try to fill these in. So we're doing the degree of each term first. Negative 6y to the fifth has a degree of 5. Negative 2y has a degree of 1 because that's the exponent on the y. The next one's been done for us. 12y to the ninth has a degree of 9, and then our constant term of 10 has a degree of 0. So comparing all of those degrees, the highest one is 9. So therefore, the degree of the polynomial is 9. That means that 12y to the 9th is the leading term. That's filled in. The 12 is the leading coefficient. And then the constant term is the one that doesn't have a variable on it, which is 10. Okay, we could do something similar with the your turn over here. There's a little more space to fill in, so let's do that as well. 12y to the 4th minus 7y to the 7th minus 6y to the 3rd, and then minus 8. Let's do the degree of each term. Looks like 4, 7, 3, and 0. The degree of the polynomial would be the highest of those, which is 7. That means we found the leading term right here, negative 7y to the 7th. That negative 7 is the leading coefficient. And finally, the constant term is that minus 8. Okay, so that was example 1 and your turn 1. Now we're going to scroll on down. Okay, the next ones are all about descending and ascending order, arranging the terms from highest to lowest or lowest to highest exponent, or degree, sorry. So for descending order, here's our first example. Negative 6y to the 5th plus 12y to the 9th minus 4y to the 3rd minus 2y plus 10. Okay, so the highest degree is this 12y to the 9th, so that goes first. Then the minus 6y to the 5th. Then the minus 4y to the 3rd. Then the minus 2y, and then finally the plus 10. That's descending order from highest degree to lowest. Ascending order goes in reverse. So take all those same terms and just write them in the opposite order. The 10 goes first, and then the minus 2y, then the minus 4y to the 3rd, then the minus 6y to the 5th, and finally the plus 12y to the 9th. Notice how I might sometimes be saying negative or minus sort of interchangeably. So if there's a minus sign or a negative sign to the left of a number, it's kind of like stuck to that term. So that minus 2y, it's always going to be minus 2y. If it were written first, I might refer to it as negative 2y, but still that sign would be there. If you have a positive number like a plus 10 or the positive 12 y to the 9th, if it's written first, there's no sign necessary, but if it comes in the middle or the end, notice how we write the plus sign. Okay, so here's the your turn version of this problem. Here's our 4 terms. Let's write them in descending order from highest to lowest. Looks like that would start with 12y to the 4th minus 6y to the 3rd. Oh, nope, just kidding. I rushed. All right, erase. I need to slow down and be more careful. My mistake. Let's slow down. I thought 12y to the 4th had the highest degree, but I was wrong. The highest degree actually is this 7. So let's slow down. What is the degree of each term? 4, 7, 3, and 0. So actually, I need to start with that leading term, that negative 7y to the 7th. Sorry about that. Next would be plus 12y to the 4th, then minus 6y to the 3rd, then minus 8. That's descending order. Now, ascending order, that's going lowest degree to highest degree. I'm going to take those same terms and just switch the order. So the minus 8 would go first, but I'll call it a negative 8 now. So negative 8 and then minus 6y to the 3rd plus 12y to the 4th. And then my leading term would actually be last if I wrote it in ascending order. All right. Let's see what we got next. Okay, so evaluating polynomial functions. We've done this before, actually, when we found function values. It's kind of more of the same. It's just that we're specifically plugging into a certain type of function called a polynomial function. You'll notice these have variables, of course. Functions always have variables, but they will have exponents sometimes on the variables. What you won't see with polynomial functions is things like square roots or absolute value or there will be other types of functions we'll see in this class. So anyway, this is just a specific type, but you're still going to just plug in. All right, so here's example 1. For the polynomial function, find f of -1. So it's f of x equals 3x squared minus 5x plus 4. And so what we're going to do is replace the x with -1. Okay, so that's what's been done in this first step here. 3 times -1 squared minus 5 times -1 plus 4. Then we simplify. Order of operations, -1 squared is +1. I would have just changed this to a +5 next, but I guess they save that for the last step. So let's fill in the blanks here. So 3 times 1 is 3. -5 times -1 becomes +5. And then we have the +4. And just add those all together. 3 plus 5 is 8. Plus 4 is 12. So our final answer is 12. We'll do the your turn over here. So different function. This time we're finding f of 2. So here's our function, -6 x to the third minus 4 x squared plus 2 times x minus 10. Let's replace x with 2. So I'm filling 2 in those parentheses. We have an exponent of 3 here, so just be careful with that. I'm going to start with 2 to the third, which is 8. 2 times 2 times 2. Bringing down the -6. So notice we did not do -6 times 2 is -12 and then cube it with the exponent of 3. So just be careful. Again, order of operations is what we're doing. So we're doing the exponents now. Moving to the next term, 2 squared would become 4. So I'm putting 4 in the parentheses. And then everything else we can just copy down. Okay, so now that we've done exponents, now we can do our multiplication steps. And there's a few of them. -6 times 8 would be -48. -4 times 4 would be -16. 2 times 2 is 4, and then minus 10. And from there, you can just add or subtract left to right. Feel free to use a calculator. -48 minus 16. Oh, shoot, and I don't have my calculator. All right. I'm just adding and keeping the negative sign. 64, that's what I thought. Okay, -64 plus 4 minus, I know you can do this part. Oops. -64 plus 4 minus 10. Feel free to rearrange them if you like to add the negatives together first, that's fine. -64 plus 4 would be -60. -60 minus 10 would be -70. All right. Very good. I'm going to briefly pause and just double check that answer before moving on. All right, I think we're good. So let's see what else there is here. I see a crossed out section. You probably don't have that in your physical handout if I've handed you something. But remember, if you see these crossed out sections on the video notebooks online, that just one of my colleagues that went ahead and did that is just crossing out things that we're not covering in this class. I've actually deleted those before printing them and handing them to you. So, all right. Next little topic here, adding polynomials. All right, you've definitely done this before if you're in this class. Combining like terms is what we're doing. All right, so similar or like terms are terms that have the same variables raised to the same powers or exponents. Polynomials are added by collecting or combining like terms. All right, I am personally not a huge fan of how this work is shown all the time, but that's just my own personal preference. I noticed that it seems like they're grouping the coefficients in parentheses. That is not my preferred way, but that's okay. It's still the same concept, and some of you might be used to showing it this way, which is great. So notice in the example, see, here's how I would do it. The -4x to the third plus the 6x to the third. I would just do -4 plus 6 and get 2x to the third. That's really what's being shown in this intermediate or middle step right here. Notice how the -4 plus 6 are put in parentheses next to the x to the third. Personally, I don't usually do that step, so I would just let you know you don't have to show quite as much detail here, but you're welcome to. If you want to just underline the like terms or rearrange them, there's not a huge amount of work that needs to be shown for all of these. All right, let's see, what else? Are there any other like terms? Notice how there's the -2x squared, but there's nothing else with x squared. So that term just stays as it is. Kind of just bring it down. And the answer, same thing with the 5x. The plus 5x has nothing else to combine with it. There's nothing else with an x. in the problem. The only other like terms are the +3 and the -7, and that's where that -4 comes from. All right, so it's kind of just matching up the terms that have the same variables and the same powers or same exponents. Here's our example 1. Collect like terms. 2x squared plus 12x minus 11 minus 3x squared minus 15x plus 6. So I'm going to just circle the like terms, and then we'll see if we can figure out what's going on in the fill in the blanks here. So 2x squared minus 3x squared. Yeah, that's the 2 minus 3 going on here. So 2 minus 3 would be -1. So I would write -1x squared or just -x squared for that first term. Next, we would have the plus 12x minus 15x. So that's what's going on in the second term here, second parentheses. 12 minus 15 is -3. So that's this -3x for the middle term. It's already been written. And finally, the last two terms are constant terms. Those are alike, -11 plus 6, and that would be -5. The minus sign's already there, so you can just write the 5 in the little box there. Okay, I think I'm just going to do the examples for this one, not the your turn problems. If you need more assistance, of course, please reach out to me and we can do some more practice if needed. All right, example 2. 4x to the third plus 5x to the third. That's going to be 9x to the third. Yeah, I would just go straight down here. I wouldn't bother writing the 4 plus 5, although you certainly can. Next, the terms with the xy. So -2xy plus 6xy, that would be, let's see, -2 plus 6 would be 4. So that's plus 4xy. And then finally, those last couple of terms with the y to the third. Feel free to write a 1 in front of a variable if there's no number there. So 1y to the third minus 5y to the third, that would be -4y to the third. So we would write -4y to the third for the last term. All right, moving on to the next example, notice how the directions say add using columns. This is a strategy you might choose. It can help you stay organized. I'm a fan of this method, actually. I feel like it's so neat and organized. So that's why I like it. So really, you're just vertically lining up the like terms. So it says, in order to use columns to add, we write the polynomials one under the other, listing like terms under one another, and leaving spaces for missing terms. Okay, so let's talk about that. What does that mean, you're leaving spaces? Notice for this first expression, 5y to the third plus 6y minus 8. See how it kind of skips over the next exponent, meaning there's no y squared term in that first expression. What you should expect is whatever the highest exponent is, you could kind of expect to count down one at a time from there. And if it kind of appears to skip a term, that's where you leave a space. In other words, there's no y squared term that is going to be combined with the plus 4y squared in the next term, in the next expression. So 5y to the third plus 6y minus 8, there's a space here. Next, we have minus 2y to the third. Just put that right under the 5y to the third. We're matching up the like terms. Then the 4y squared, see, if we didn't leave a space, it would have nowhere to go. Okay, but it just gets its own column. There's nothing else to be combined with it. Same thing with the 6y, okay? There's no other y term to be combined with that, so it gets its own space as well. And finally, those constant terms at the end, the -8 and the -4 are in that very last column. So then we just add the coefficients as we're combining like terms. So 5y to the third minus 2y to the third is 3y to the third, plus here we have just 4y squared, and then plus 6y, and then minus 12. All right, there we go. Okay. Next, we're going to subtract polynomials. So my approach to subtracting polynomials, it's very similar to adding. It's just that you're adding the opposite. So there will be this extra step of distributing a minus sign or distributing a -1. Okay, so let's see. They're giving you the definition of opposite. You're basically changing the signs. To subtract a polynomial, we add its opposite. Okay, Now it's talking about what does that mean, opposite. So let's see, write two equivalent expressions for the opposite of this polynomial. Okay, so the opposite literally just means you have a minus sign in front of it in parentheses. Then you can distribute that minus sign, I'm writing some arrows here, and essentially change the signs of each term. Okay, so the opposite can be written without parentheses by replacing each term by its opposite. In other words, you're changing each sign from positive to negative or vice versa. So notice in this example, subtract negative 4x squared plus 3x minus 1 in parentheses minus 10x squared minus 6x minus 8. I would distribute that minus sign to change the expression to its opposite. Okay, so notice how the 10x squared now becomes minus 10x squared. The minus 6x now becomes plus 6x. The minus 8 becomes plus 8. Then you just combine like terms, like normal. Okay, so once you change the signs of the second expression, then you're able to combine them just like you did in the adding examples. Okay, let's move down and see what we're being asked about opposites. Write two equivalent expressions for the opposite. Okay, so the first one is just, you can write it with a negative sign in front of the parentheses, or you can also replace each term by its opposite. In other words, you can distribute that minus 1 or that negative sign, treating it like a negative 1 or a minus 1, and change each sign. So that's where the negative 3x squared comes from here. The negative 2xy becomes plus 2xy. The plus 4y becomes minus 4y. The minus 12 becomes plus 12. So really quick, the your turn, we'll just do this one. Write two equivalent expressions for the opposite. The first thing I'm going to do is rewrite this polynomial in parentheses with a minus sign or a negative sign outside it. So negative parentheses, negative 6xy squared plus 5xy minus 16y plus 20. So that's technically the opposite. Another way to write it, so it says write it two ways, two equivalent expressions. Another way to write it is by changing each of those signs. And that allows you to write it without parentheses. So now I can write positive 6xy squared minus 5x plus 16y and minus 20. Those are both equivalent. Okay, this is getting us ready to actually subtract. So example 2, subtract. I'm going to start by adding the opposite. So it's negative 7x to the third plus 5xy minus 1 minus 15xy plus 7. Notice how we can change each of the signs in that second expression. So it becomes minus 15xy and then minus 7. Then we get to combine like terms. So our final answer would be negative 7x to the third. And then let's see, the 5xy and the minus 15xy become minus 10xy. And finally, the minus 1 minus 7 becomes minus 8. Okay, I'm going to just take a little look ahead to see if there's another example we can do or if we want to do the your turn. Oh, yeah. All right, let's do the example and the your turn with the fractions. That'll be good, and that'll be a good little review of fractions. All right, so example 3, we'll do the example and the your turn. So we're subtracting 1/4 x squared minus 5/8 x plus 1/2 minus 3/4 x squared plus 3/8 x minus 1/2. All right, so we're going to distribute that minus sign first, essentially adding the opposite. So that's why the 3/4 is now negative 3/4. The 3/8 is now negative 3/8. The negative 1/2 is now plus 1/2. Okay, and let's see. What are we filling in this next spot? I think we're just rewriting it without parentheses. So instead of writing plus negative 3/4 x squared, we can just write minus 3/4 x squared. Okay, from here, we're combining like terms. I think we're pretty lucky that the like terms already have common denominators, which is pretty handy. So notice that the x squared terms both have a denominator of 4. So 1/4 x squared minus 3/4 x squared. Keep the 4 as the common denominator. 1 minus 3 is negative 2. So that's where the negative 2/4 x squared comes from. Then negative 5/8 x minus 3/8 x. If you combine those fractions, that becomes negative 8/8 x. And then the last terms, 1/2 plus 1/2. If you keep the common denominator of 2, that's 2 over 2, which reduces to 1. So that's where the plus 1 comes from. And the other fractions can be reduced as well. So negative 2/4 reduces to negative 1/2. So our final answer is negative 1/2 x squared. And then minus 8/8 x, that becomes minus 1x. And then the last term is plus 1. Let's try the your turn version so we don't have such a crowded view of all these fill in the blanks. Let's do it from scratch ourselves here. Okay, I'm going to clear what I've written already, and I'll zoom in to give a little more space. Go ahead and start by distributing that minus sign so that we're adding the opposite of the second expression. And that's what I'm showing with these arrows here. So when I rewrite this, this is going to be 7/9 x squared minus 2/3 x plus 5/6. And now for the second expression, negative times negative, this is now plus 2/9 x squared. And now this becomes minus 1/3 x and plus 1/6. Now we can start combining like terms. I think just like the example, the like terms happen to also have common denominators. That's not always going to happen, but it's nice that it does here. 7/9 x squared plus 2/9 x squared is 9/9 x squared. It's just going to become 1x squared in the final answer. Then negative 2/3 x minus 1/3 x, that becomes minus 3/3 x, which is just going to be minus 1x in the answer. Noticing a theme here. Plus 5/6 plus 1/6, that's plus 6/6, which reduces to 1. There you go. So x squared minus x plus 1. All right, well, that wasn't as hard as I thought. I was thinking we would need to get common denominators, but they were already there for us. So that wasn't as bad as I thought. All right, I'm clearing that. I think we're almost done with this section. Yep, I think now we're at the practice exercises section. So I'm going to leave that. You do have answers available in the learning and lecture materials page back in Canvas. There is a link for the answer key. So you can try the practice exercises and check your answers, or if you feel ready, you can probably just go ahead and work on the homework. The practice exercises are not required. They are optional. All right, I'm going to end this video here, and I'll make a similar one for section 4.2. All right, thank you.